All right, so we're going to take a look at the Chapter 6 Extra Practice Test Prep. This is essentially your review. So we're going to do a video review key just to make sure everyone is on the same page. All right, so Unit 6 review. All right, so the first part of this asks us to simplify the cube root of negative 729. So essentially we're looking to see, is there something times itself 3 times that gives us negative 729? Well, I happen to know that the cube root of negative 729 is just negative 9. And oops, there we go. It's just negative 9. And so that's our answer. Question 2, we've got the fourth root of 16x to the 16th, y to the 20th. So first thing we need to do is figure out, is 16 a perfect fourth root? Or can we take the fourth root of 16? Well, I know that 2 times 2 times 2 times 2 equals 16. So the fourth root of 16 is just 2. Since 16 here on our exponent is divisible by 4, we'll go ahead and divide it. So x to the fourth. And then here, since 20 is divisible by 4, we'll go ahead and divide it, y to the fifth. So we're able to take the fourth root of each of those, so that's good. Here we've got the fourth root of 7x to the sixth times the fourth root of 32x squared. So in this case, the items are not the same. We're going to multiply them together. Since the indexes are the same, we're going to multiply what's underneath together. We'll take coefficient times coefficient. So 7 times 32 is 224. X to the sixth and x squared becomes x to the eighth. And we're going to put that back underneath the fourth root. So in this case, I'm looking for a number that I can take the fourth root of out of 224, so I can break this apart. So let's see if we can't find something. We'll think small. Well, we just talked about this. We know 16 comes out of, or is a perfect fourth root item. So let's say, what is 224 divided by 16? So 224 divided by 16, that's going to give us 14. So let's say we break this apart into the fourth root of 16 and the fourth root of 14. Well, we're not going to be able to do anything with the 14, but we know the fourth root of 16 is 2. So what we end up with here is we've got 2, and then we can bring out the fourth root of x to the eighth, which is just x squared. And then back underneath our fourth root radical is just going to be 14. So there's our answer. Question 4 here, we've got the cube root of 75x to the seventh, y to the second, and the cube root of 25x to the fourth. Keep in mind that even though these are under separate radicals, we can kind of address it as just being under the same radical, which will allow us to simplify down the road. So 25x to the fourth. So with our coefficients in this case, or our numbers, we'll take 75 divided by 25, which is 3. And then we'll subtract the exponents on the x's, so that's x to the third, and then y squared. We can, in this case, only take the third or cube root of x to the third, so we'll carry out an x, cube root of 3y squared, and that is our answer. Question 5, we're looking to add radicals here, but they have different values underneath the radical sign, so we want to see if we can simplify. Well, I know this breaks down into the square root of 9, square root of 2. This is going to break apart into the square root of 16 and the square root of 2. So here, the square root of 9 is 3, so I've got 2 times 3 times the square root of 2. That's 6 square root of 2, plus square root of 16 is 4, 4 square root of 2. Now that they're the same values under the radical, we can add the coefficients. So 6 plus 4 is 10 square root of 2. Question 6, this is multiplication, and essentially what we're doing is we're foiling here. So first times first, so that's 1. Outer, so we multiply the 1 times the 3, so this becomes 3 square root of 3 again. Then square root of 3 times 1, so that's another 3 square root of 3. And then 3 square root of 3 times 3 square root of 3. And the 3's get multiplied, you get 9. The square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is just 3, so we're multiplying 9 and 3. So we've got 1. We'll go ahead and combine like terms here. Plus 6 square root of 3. Plus, in this case, 27. 1 and 27 gives us 28. Plus 6 square root of 3. And that's our answer. All right, keep going here. We've got 16 to the 1/4 power. Well, remember when we're looking at this problem, we know that the top is the power and the fourth is the root, or in this case, the index. So if we wanted to, we could change this into a radical. This is the fourth root of 16, and we've actually seen this a lot on this paper. We know at this point that the fourth root of 16 is just 2, since 2 times 2 times 2 times 2 is 16. All right, question 8. 7 plus the square root of 5 over 6 minus the square root of 5. Here we want to rationalize the denominator by multiplying the top and bottom by the conjugate of the denominator. So 6 plus the square root of 5. To simplify this, we're going to FOIL both the top and the bottom. So across the top, 7 times 7 is 42. 7 times the square root of 5 is 7 square root of 5. 6 times the square root of 5 is 6 square root of 5. And then square root of 5 and square root of 5 multiply together to give you square root of 25, which is just 5. Then on the bottom, we're multiplying 6 minus square root of 5 times 6 plus square root of 5. So this is going to give us 36 plus 6 square root of 5 minus 6 square root of 5, and then minus the square root of 25. The square root of 25 is just 5. So now we can simplify some things. We're going to combine like terms here. So, and then we're going to combine the 42 and the 5. So that's 47 plus 13 square root of 5 over, this cancels, and we get 31. So this is your answer. For question 9, remember we've got the power and then we've got the index or the root. So we can change this. This is going to be the cube root of 8, a to the negative third, b to the ninth, all of that squared. Oops, my handwriting's a little bad. There we go. We can start to rewrite this. So we've got the cube root of, let's fix that. Cube root of 8, and then we'll say b to the ninth, and we'll drop the a to the negative 3 underneath, so that way we can have a positive exponent, and then all of this is squared. So now we can kind of start pulling out our perfect cubes, or cube roots here. So cube root of 8 is 2, cube root of b to the ninth is just b to the third, a to the third cube root is just a, and then we're going to square all of this. And so we can finalize this or simplify it completely out with 2 squared is 4. In this case, we're going to get b to the sixth. And then here we've got a squared. For question 10, it says y equals x squared plus 4. Find the inverse. So to find the inverse, we're going to trade the places of the x and the y. So we've got x equals y squared plus 4. And now we want to solve for y. So we'll move the 4 by subtracting it. So x minus 4 equals y squared. We'll then square root both sides. And when we square root this, we're going to get plus or minus the square root of x minus 4 equals y. So if we want, we can rewrite this so it looks a little nicer. Or we can write it in function notation where we've got the inverse, or f of inverse of x, equals plus or minus the square root of x minus 4. Question 11 wants us to find the inverse. And so remember, when we're talking graphically, to find the inverse, we are going to essentially trade the location of the coordinate values of the x and the y values. Or some of you might remember that we're essentially just going to reflect over this line here. And so as we do this, we can see that this point here is 0, 2, so it's going to become 2, 0. And then we're going to 1, 3, so this becomes 3, 1. We've got 2, 4, so this becomes 4, 2. And then we're just kind of trading the points off here. And so our inverse graph looks like this. And so this is the graph of our inverse. We've got f of x here, and this would be f of negative x, or the inverse. What you should also remember in this case, for this problem, is that this particular graph here is not a function. So our inverse in this case is not a function. It essentially fails the vertical line test right here. So that's not going to be a function. All right, on to the back. It says graph each function and its parent function. Describe the transformation. All right, so this, I know that the parent function for this graph is going to just be y equals the square root of x. So if I were to graph this, I know I've got points here, here, and so my graph looks like this. So this is y equals the square root of x. Then we're looking at this particular equation here. Since they give us y equals negative 2 square root of x plus 1, we've got to figure out what transformations take place. Well, we know that the negative in front, this negative in front, means it's translated across the x-axis. We know that the 2 in this case is going to be stretched by a factor of 2. And then we know that the plus 1 here means we are, oops, that's not what I wanted. Where'd it go? It means it's translated left 1. And so we can put all these together in order to graph our new function. So I'm going to use purple. So here's our first point, and then our second point will be here. And so this is our graph, looks something like this. All right. So keep in mind, if you wanted to see the procedure or the process to get to that particular point, one of the things you have to keep in mind is for that negative, your graph is going to flip over and do something like this, and I'm going to get rid of these in a second. Oops. So you've got your, after you're translating over the x-axis, we're here. And then from there, you're essentially moving over one to the left. So that puts you over top of this, so you're here. So we can kind of erase some of this stuff. Then you move one to the left, so you're here, and you're here. And then if you think about the stretch by 2, you're essentially just doubling those values, and that brings you down to the purple graph. And so our parent function is in red, our translated or our transformed function is in purple. All right, so here we want to perform the function operations. So for the first one, the function operations here are, we're adding the f and g functions together. So since that's the case, we've got x plus 1 plus x squared. So that means our answer is just going to be x squared plus x plus 1. Here, f minus g. So x plus 1 minus x squared. We can rewrite this in standard form, x squared plus x plus 1. Here, this is multiplication, so we've got x plus 1, and we're going to multiply that by x squared. So our answer becomes x cubed plus x squared. Here is division, so we've got x plus 1 over x squared, and that's all we can do with that one. And here what we're looking at is we have f of g of x, so that means we're plugging x into the g of x equation, which in this case means it's just going to be x squared. So we've got f of x squared, so we're plugging x squared into the f of x equation, which gives you x squared plus 1, so it replaces the x. And then here we've got g of f of x. So we're going to start with the f of x, so that means this part here is just x plus 1. And then we're going to plug this into the g function, and so g of x plus 1 is going to give us x plus 1 squared, which in this case, if we FOIL this out, we get x squared plus 2x plus 1. And then at the bottom it says solve each equation, check for extraneous solutions. So for the first one, we've got 3x plus 4 to the 1/2 power minus 1 equals 4. First thing we want to do is add 1. So 3x plus 4 to the 1/2 power equals 5. To get rid of the 1/2 power, we're going to raise both sides of this equation to the 2/1 power, or just 2. So that means on the left, we are left with 3x plus 4, and then on the right, we have 25. We're going to solve this. We'll subtract 4. We get 3x equals 21, divide by 3, x equals 7. So our goal here is to then test 7. So we've got 3 times 7 plus 4 to the 1/2 power, or the square root, minus 1 should equal 4. So that's 21 plus 4 is 25. So 25 square root of 25 minus 1 equals 4. This is 5 minus 1 equals 4. So 4 equals 4. So we're good. All right, second problem. We want to solve this. X equals the square root of x plus 7 plus 5. We need to move the 5 to the other side. So x minus 5 equals the square root of x plus 7. We're going to go ahead and square both sides of this in order to get rid of the square root. So we're going to raise it to the second power. All right. On the left, we're going to have to FOIL this out. So we've got x squared minus 10x plus 25 equals x plus 7. Here we're going to go ahead and move the x plus 7 to the other side, so it's set equal to 0, so we subtract it. So x squared minus 11x plus 18 equals 0. In this case, we can factor this. Two numbers that multiply to be 18 but add to be negative 11 are negative 9 and negative 2. And so we're going to solve both of these by setting them equal to 0. So x equals 9 and x equals 2. Well, we just need to test for extraneous solutions. So we'll plug it back in. We've got 9 equals the square root of 9 plus 7 plus 5. 9 plus 7 is 16. Square root of 16 is 4. So 4 plus 5 equals 9. So that's good. So 9 is a good solution. And then we'll try 2. So 2 equals the square root of 2 plus 7 plus 5. This is 9. 9 square root is 3. So 3 plus 5 does not equal 2. So 2 is not a good solution. It's extraneous.